Okay, so this video is on arc length. And before we really, well, let me first define what arc length is. So if we're looking at a circle, the measure of the entire outside of the circle is called the circumference. But let's say we have the center of our circle and we have point A here and point B here. If we were to measure from point A to point B, that would be the arc length. It would be the measure of the arc AB. So that's kind of what arc length is. Before I get into how to find it, I want to talk about the difference between radians and degrees and how to convert back and forth between the two. So if we start by looking here at these two formulas, one is given, this is how, if we're given degrees, how we can write it in radians, or if we're given radians, how we can write it in degrees. So if you're looking for radians, you want it written in radians, you're going to use this formula. If you're trying to convert it to degrees, you're going to use this formula. And it really just depends on what you're trying to solve, whether it's nicer to have it in degrees or nicer to have it in radians. So we just want to be able to switch back and forth between these two types of things. So to start, I have 60 degrees, and I want to convert that to radians. So I'm going to use my radians formula, which is degrees times pi over 180. So I have 60 degrees times pi over 180. And my biggest recommendation to students is to just be careful when you're typing this into a calculator and just put as many parentheses as possible to make sure that it's doing it in the right order. So if I were entering this in a calculator, I would enter 60 times, in parentheses, pi divided by 180, just to make sure that everything is entered in there perfectly and I don't have any mistakes just due to calculator error. And when I enter that in a calculator, it comes out to about 1.05, and this is radians. So 60 degrees is the same as about 1.05 radians. Well, let's say I'm given radians and I want it degrees. So now I'm going to use the degrees formula, which is radians pi over 4 times 180 over pi. So again, when I enter this into a calculator, I'm going to be very careful and just do pi divided by 4 in parentheses, multiply that by 180 divided by pi in parentheses. So when I enter that into my calculator, I'm left with 45 degrees. So pi over 4 radians is the same as 45 degrees. So the rest of these problems are very, very similar. We're just converting back and forth. So I'm going to not show how to enter it in your calculator, but I'll still show you kind of which formula I'm using. So 90 degrees, I want it in radians. So radians formula is 90 times pi over 180. And this simplifies to pi over 2, 90 times pi over 180, which is about 1.57 radians. And then here I'm given 105 degrees, so I'll use that same formula. I'm trying to go to radians. 105 times pi over 180. And this one's equal to about 1.8 radians. And then these last two, I'm going the other way. I'm given radians, I want degrees. So using the degrees formula, I have pi times 180 over pi, which this one I don't even have to enter into a calculator because these pi's cancel out. So pi radians is the same as 180 degrees. And then the next one, using that same formula, it's radians times 180 over pi, which is equal to 270 degrees. So that just kind of shows how to go back and forth between radians and degrees. And then I'm going to go ahead and show you how to find arc length, which is the main discussion of this video, using both radians and degrees, whether you're given your angle in either measure. So we have two formulas down here for the length of an arc. The first formula on this side is using degrees, and then the formula over here is using radians. So I'm going to start by looking at the degree formula. And I notice right off the bat that in this arc length formula, I have 2 pi r, which I happen to know is the formula for circumference. So that's kind of interesting. So I'm multiplying the circumference by whatever my angle is divided by 360. Well, that makes sense and is noted right here in this notice that to find the length of an arc, you just multiply the circumference of the circle by the fraction of the circle that the length takes up. So if I do n over 360, that's whatever fraction of the circle I'm dealing with. And then if I multiply that by my circumference, I can end up with my arc length. So in this example, it says my radius is 7, and then this angle is 80 degrees. So using this formula, I have 80 degrees divided by 360 degrees times 2 pi times the radius, which is 7. And then when I enter this in my calculator, just like the ones above, I'm going to do 80 divided by 360 in parentheses. And then I'm just going to put it all in. So in parentheses, I have 80 divided by 360 times 2 times pi times 7, which gives me about 9.8 for my length. Versus over here, I'm given my angle in radians and not in degrees. Well, when given your angle in radians, it's actually even easier. This little symbol, and I suppose this should actually be a theta this time, not an n. This little symbol is called theta, and it's just your angle measure. So the arc length is just your radius times your angle measure. So all I have to do over here is 7 times 1.4. So it's even easier than when we're given degrees. And this is also 9.8 because 80 degrees is the same thing as 1.4 radians. So we're going to go ahead and find a few more arc lengths just to make sure that we're all confident in what we're doing. So we're finding these arc lengths down here. This first one is 3 over 3/4 pi is my angle, and then my radius is 8. And since this is in radians, all I have to do is multiply these two. Again, in my calculator, I would enter this as 3 pi divided by 4, and then multiply that by 8. So if I have that in my calculator, 3 pi over 4 times 8, this ends up actually simplifying to 6 pi, which is the same as about 18.8. So my arc length here is 18.8 or 6 pi. So this is equal to my arc length, which in this case was S. Number 8, I'm in degrees, so I've got to make sure I use the degrees formula for arc length, which is 60, my angle, over 360, and I'm going to put that in parentheses in my calculator, times 2 times pi times the radius, which is 9. So I'll go ahead and enter that in my calculator. Times 2 times pi times 9, and this ends up as 3 pi, which is also equal to about 9.4. And this is the measure of the arc from P to Q, is equal to this. Number 9 is very similar. It's also given in degrees, so this time I have 90 over 360 times 2 times pi times 5, and then again that 90 over 360 is in parentheses times 2 times pi times 5, and this ends up at about 7.9, which is D. So those are just a few examples of how to find arc length. The next couple of examples I want to show you are in story problem form, so we're going to have to figure it out a little bit more. So number 10 says the minute hand of a clock is 4 inches long. And we're going to assume that our minute hand goes from the center all the way to the edge of our clock, which would mean that the radius of our clock is 4 inches long. And then if the hand moves from 105, okay, so I'm just worried about the minute hand. So if the minute hand is at 05, it's going to be right here, to 25, 125, it's going to move from there to there. And it wants to know the distance that this moves. So it wants me to find this arc length. So if I call this point A and this point B, I'm looking for the measure of the arc AB. So first, in order to find that, I know my radius is 4 inches, but I need to know what this angle measure is. So I can figure that out because I know that the degrees of the entire circle, the whole circle, is 360 degrees. And then there's 12 numbers on that circle, and there's 12 spaces between numbers. So if I do 360 divided by 12, that gives me 30 degrees. So between 12 and 1 is 30 degrees. Between 1 and 2 is 30 degrees, and so on, all the way around the circle. So if I'm trying to figure out how many degrees it is from here to here, I can just add these up or multiply them. So I have 1, 2, 3, 4 30 degrees. So 30 times 4, that angle is 120 degrees. So once I have this information, I can use the formula I used above, which was 120 over 360 times 2 times pi times the radius. And if I enter that all into my calculator, I get approximately 8.4 inches is the length of this arc. So I'm going to go ahead and erase what I've written on this clock so I can rewrite with my new information. So we have a standard 12-hour clock. This one has a radius of 3 inches, so it just tells me. So on all of these, my radius is equal to 3. What is the length of the arc between 3? So I'm going to start at 3 and 8. Ooh. So I'm trying to find the length of this arc right here. So I already discovered before that each of these is 30 degrees. So I have 1, 2, 3, 4, 5 30 degrees. So this is 150 degrees. So 150 degrees is my angle. My radius is 3. So I have 150 over 180 times 2 times pi times the radius of 3. If I enter all of this in a calculator, 150 divided by 180 times 2 times pi times 3, I get approximately 15.7 inches. 12 is asking the length of the arc between 3 and 4, so that's just right here, which is just 1, so this is just 30 degrees, so I'm going to have 30 over 180 times 2 times pi times 3, which is 'Okay, I'm going to have to go back on numbers 11 and 12 because I have 180 here and I should have 360 here. So hopefully those of you watching caught that mistake. So let me just re-enter that in each of those in my calculator to make sure we have accurate answers. So back to number 11. This is actually half that, so instead of 15.7 inches, I should end up with 7.8 inches. And then on number 12, I have 30 divided by 360 in parentheses again, times 2 times pi times 3, and this is about 1.57 inches. Then I'm going to go ahead and draw a picture for my last one, and I'm going to preface it by saying that it's not entirely accurate, because it's telling me that it's 135. So I'm going to draw 135 as if it looks like this. But we know that it doesn't. If it was actually 135, the hour hand would be between the 1 and the 2. So I'm just doing it like they do it in elementary school for simplicity's sake. So I'm still trying to find the arc length from the 1 to the 7. So this one's actually really easy because it's half the circle, which the circle is 360 degrees, so half the circle is 180 degrees. And then the same process times 2 times pi times 3. Enter that in a calculator. And this ends up as 3 pi or about 9.4 inches.